Hello, welcome back. So this will be for the linear probing already with the same problem. So for the linear probing, this is definitely a different implementations as we will begin to run through this with in a step-by-step process as well. So suppose that we'll begin to use as well the same m is equals to 10. So insert 27. So once we insert 27, calculating the modulo of 27 over 10. So 27 divided by 10 will become 2. 2 times 12, 2 times 10 will come 20 minus 27 equals 7. 7 will be the remainder for this one. Now, checking the index number 7. So considering that index number 7 is empty right now, so definitely we can just simply allocate that one, 27. So therefore, 27 will be here. So please be reminded that in your linear probing, we are not allowed to insert many um, element in our placeholder. It must be one because this is actually behaving as array. So this is stored in a contiguous manner. So of course we cannot insert anymore if ever that there will be a data collision. But for data collision, what happen? We'll do the linear probing definitely. So suppose that we'll begin to insert 67 right now. Considering that 67 modulo of 10, when you calculate that 167 divided by 10 will become 6. 6 times 10 will become 60. 60 minus 67 will be 7. 7 will be the remainder. So index number 7, next number 7 is actually taken. So what we'll begin to do? In our linear probing, the formula for that one is actually index plus 1. And of course, if ever the 10 and so on and so forth, you will begin to get the modulo of m still. Now, for this one right now, index number 7 is taken. So you just have to plus 1. So index number 7 equals 7. Index 7 plus 1 equals 8 will become index number 8. And is it empty? That is empty. So therefore, you will store the 67. So right now, 67 will be stored here in your index number 8. Now, since we're done with the 67, let's try to insert number 97. Now, 97 modulo of 10, you will be going to certainly check that one. 97 divided by 10 will become 9. 9 times 10 will become 90. Then 90 minus 97 equals 7. So the remainder is 7. So therefore, checking the index number 7, so that is taken. So therefore, you will begin to deal with index 7 plus 1 equals 8. So index number 8 was taken and index plus 1 plus 9. So checking index 9. So index number 9, that is empty. So therefore, we can allocate definitely 97. So 97 will be stored over here. So that's how you will organize that one. We're done 97. Let's deal with 42. Insert 42. Now, for 42, 42 modulo 10, 42 divided by 10 will become 4. Then if we'll begin to multiply by 10, it will become 40, and the remainder will become 2. So therefore, 2 is the answer. So index number 2, checking the index number 2, that is empty definitely. So we can just simply allocate this one. So 42 will be allocated in your index number 2. Now, since we're able to allocate that one, we're done with the 42. Let's go with 33. Insert number 33. So for 33, modulo of 10 equals 33 divided by 10 equals 3. 3 times 3 10 equals 30. 30 minus 30, 33 equals 30 equals 3. So therefore, the remainder is 3. Checking index number 3. So in your index number 3 right now, that is empty. So therefore, you will just keep on, you will just have to put, to allocate 33 right there. So once you will begin to insert number 74 right now, okay, 74 modulo of 10, well, 74 divided by 10 equals 7. 7 times 10 equals 70. 70 minus 74, that is 4 remainder. So, therefore, index number 4, let's try to see index number 4, if that is allocated or not, that is empty. So, we're able to forget 33 here. So, 4 is empty. So, it will become allocated 74. So, 74 will be here. Now, we're done with 74. Let's move on with 94. Insert 94. Make sure that you will follow the flow, ha? You just have to base here then. Now, um, 94 will become 94 modulo of 10. 94 divided by 10 equals 9. 9 times 10 equals 90. 90 minus 94 equals 4. So therefore, 4 is your answer right now. By the way, we're not able to indicate here then that this is empty. Okay? You just have to simplify that there is no element or empty so that we can simply allocate 74 here. So what will gonna happen, index number 4, then empty, and then 94. So that's how you will begin to allocate. No, no, no. That's not empty. If you'll begin to check index number 4, that is there is 74. That is already taken. So therefore, taken, what will gonna happen, you will begin to index 4 plus 1 equals 5. So therefore, index number 5, sorry to check in the index number 5, that is empty, and allocate 94. So that's really so hard. Now, index number 6. No, no. Number 102. Insert 102. So 102 modulo of 10 equals 102 divided by 10 will become 10. 10 times 10 equals 100. 100 plus 102, that is 2. So therefore, we can allocate that in your index 2. But before, we have to check number 2 that is already allocated. So taken. So what we can do for the data collision, index plus. So index 2 plus 1 equals 3. So check index number 3 if that is empty or not. So index number 3 is being allocated. So therefore taken, and then index 3 plus 1 is 4. Checking index number 4. Cross checking index number 4, that is taken as well. So therefore we can just simply put taken. And then index 4 plus 1 plus 5. So index number 5, that is for index number 5, that is allocated. So therefore you can just simply increment still index 5 plus 1. So it will become 6. So index number 6, it is let's try to 6 index 3, check number 6, that is empty. So therefore we can allocate in your index number 6. So 102 will be placed in your index number 6. So afterwards 34. Let's try to see insert, excuse me, 34. 34 divide modulo of 10. So 34 divide 10, that is 3. 3 times 10, 30. 30 minus 34 is 4. So index number 4. I know that this is really taking a lot of time, but that's the life here. So this is the really this is gonna be exciting. So index 4 is taken. So probe index 4 plus 1. So 5. Index number 5 was taken still because index 5 plus 1 equals 6. So index 6 is taken. So therefore, index 6 plus 1 equals 7. Now, index number 7, let's try to see that is allocated. 7, 8, 9 is allocated. So index 7 was taken. So index, I'm so sorry, it went off. So let me just pause for a while. Okay, there you go. Let's try to continue. So that is already taken. So therefore, index number 7 plus 1. So it will become 8. Checking index number 8. So next number 8 is what we have mentioned here. 8 and 9 is taken also. So it will be taken. So index 8 plus 1 equals 9. So index 9 is already taken also. And index 9 plus 1 equals 10. So since 10, that's what we have mentioned here then, that if it will increase with the index plus 1, for example, your index is, your m is equals to 10, so of course we'll be going to, if the answer will become 11 and so on and then and so on, we'll begin to deal with the modulo of m still. So 10, great, getting modulo again over 10. So 10 divided 10 equals 0. So 10 times, oh, no, 1. 10 times 1 equals 10. 10 minus 10 equals 0. So therefore, 0 is the modulo. So therefore, checking index number 0. So index 0, let's try to see index 0 is empty. So therefore, we can just simply allocate this 34 in your index 0. So insert 34. Now, let's try to insert number 2. In the insert number 2, just say insert 2. 2, right? Okay. Now, for this one, what will gonna happen? You will begin to deal with 2 divided by 10. So that is 0. 0 times 10, 0. Minus 2 that equals 2. So therefore, index number 2. Now, checking index number 2. Let's try to check if index number 2 that is allocated up until 9. So therefore, it's gonna be fun also. So index number 2 will become taken, then equals index 2 plus 1 equals 3. Index 3 is also taken. So you cannot make it shortcut because in your process, actually in terms of coding, it will not be going to assume index 4 is also taken. It will not assume that it will be inserted in that given particular index, because we need to do it step by step. So make sure to really do it as like this still. So index 5 is also taken. I know that it is quite tiring, but this is the beauty of algorithm. Index 6 is also taken. So keep on checking. Then index 7 is also taken. Index 8 is also taken. Have to do the algorithm over and over. Index 9 is also taken. So 10 become 10 modulo of 10 become 0. So index 0 is already allocated, taken. So index 0 plus 1 equals 1. Index 1 equals, so index 1, that is empty. So therefore, index 1 is empty. We can store 2 here. So imagine how it will take a lot of time. That right now we can insert last will be 9. So for inserting number 9, it will be like this, because this is really, you need to make sure that you have to work on this carefully. Okay, I know that the hash table is full, but you cannot just simply say that it's full if you will not be going to do it step by step. You really need to check it before you will mention that it is already full. So 9 modulo of 10, it will become 0. I mean 9 divided by 10 equals 0. 0 times 10 equals 0. Minus 9 equals 9. So modulo will be 9. So checking index number 9, that is taken. So since everything is taken, you have to do the algorithm. 9 plus 1 up until magbalik siya sa 9. Okay? So index 9 plus 1 equals 10. Calculating the modulo 10 over 10. So sorry. 10 modulo of 10 will become 0. Check index 0. Index 0 is taken. So, plus 1 na naman. Index 0 plus 1 equals 1. So, index 1 is also taken. So, therefore, ma-plus 1 naman. Index 1 plus 1 equals 2. Index 2 is taken. So, you can just simply say index 2 plus 1 equals 3. So index 3 is also taken. And then index 3 plus 1 equals 4. And then index number 4 equals taken. And then index number 4 plus 1. And in the equals 5. Index number 5 is also taken. And then index 5 plus 1 equals 6. Index 6 is, so sorry, taken. And index number 6 plus 1 is 7. So index 7 is also taken. So index 7 plus 1, that is 8. So index 8, I know it will take so long, but this is gonna happen. Index 8 plus 1 equals 9. So index 9 is already looping back. So taken. So of course, you can just simply say that hash table is full. Cannot insert, insert, cannot insert 9. So therefore, cannot insert 9 since we are not doing the resizing, because if we will do the resizing, of course, we will be going to recalculate, do the rehashing, and of course, it will take a end step, and of course, you will really cry the algorithm of hashing. So that's why we'll keep as is. You have to follow this one, and you have to make it step by step. So see the, if you can check here and the process that we're able to do the algorithm, this is really taking a lot of time, but of course that is really the beauty of data structures and algorithm. You have to make it step by step. So In the next video, I'll be going to do the linear probing searching operation also. Thank you so much and see you in there.